Is I am audible? Please confirm. Hello. Anyone, please confirm that is I am audible. Okay. So yesterday we have go through the. Uh, please can you log the. So yesterday we have gone through the roadmap of AIML. Okay. And we have planned that today we are going to complete regressions program. Okay. So I'm going to share you my script. Okay. So if anyone have any questions, any doubt, then please ask me. Okay. So firstly, we have to understand one thing. Okay. Like we have multiple data, and our target was our target is to minimize the error from any AI model. Okay. And also, and the error should be going to be predicted by the model only. Okay. So before knowing that one, firstly we will understand what is maxima and minima. This is in differential calculus. So maxima and minima. Okay. How this will be look like? I am just going to give you an overview. Okay. So see, this is the your graph of a error. Okay. And if you are this one will be error, and this will be your any value x, anything, whatever value we are going to choose for the model. So our target will be to reach to the here. Okay. And how we are going to find this one? We are simply going to create one slope, and slope or tangent. We tangent. Okay. Tangent, that is nothing but tan theta. Tan theta with respect to x-axis should be tan 0, 0 degree. It means that this will be the parallel to the x-axis line. If we understand that our slope is going to be parallel to the x-axis, it means that we have reached to the local or global minimum. Okay, this is a core concept of the minimum and maximum, right? So or what you can also write this one as a slope will be 0. Okay, our target is to come here. Okay, for just I'm going to give you just one example. Okay, let that this is the function graph. Function, what is this one? This one is just like a AI model. Okay, AI model to predict the errors, minimize the error. Okay, let I am going to just give you one example. Ax square equal to 3x plus 2. This is our normal equation. So how we are going to find out? Means this in these equations, every point will be considered as a fx equal to x square minus 3x plus 2. Either we are in here or here or here, it doesn't matter. But so how we are going to find out? By using dy by dx. Okay, differentiation. Firstly we are going to differentiate this one. D you have already known, right? Dy by dx. This dy is nothing but function of fx. This is the general sense of the mathematicians. Y is always a fx. Okay, this is a different way to represent your symbols. Okay, so currently we are going to find out dy by dx. How? 2x means it will be become 2x minus 3. So what we will get? 2x minus 3. And our target is to find the value of x. So we are just going to put Uh, so we are just going to put 2x plus minus 3 global minimum, and this one will be error. I will tell you, just I am explaining you minimum and maximum, focus on that one. And I will be explaining you in linear regressions and in depth, and how mathematics are working around the what we'll say in AI. But one point sorry, not approximate, correct, 1.5, 1.5, okay, right, 1.5. Let me small this one. 1.5, right? Means our x value should be, whenever our x value will be in 1.5, then our global minimum will become 0. It means that we have reached to the this point, right? This point, and this is all our targets to do. Now, one more thing, we know that the equation of a line, y equal to mx plus b, where b is interceptor and m will be the slope. Okay, how this equation is going to help us in linear regressions, now I am going to explain to you. Just stay focused. To explain all the data points to the line. So whenever new data point will become, we can easily predict with going to by using these equations, we will find the value of y. Yesterday I have told you, right? This will be our x-axis, this will be our y-axis. So how we will get this line? This line is simply nothing but this is the equation of a line, and by using this equation of a line, we can get this line. Okay, and this x value, I'm just going to explain you this whole uh, equation. Y is line. This is y line. Axis of y, and this is the for the line of equations. Okay, so whenever you are going to change the slope of the line, this line will is going to be move like in clockwise or anti-clockwise. Okay, if you are making changes on the y. Okay, 1 second. Yeah. Like currently this line is like this. Maybe after making changes on the m, you are going to get new line as a this. After that, you are going to get like this. So whenever you are going to change in m, your line position is going to rotate throughout the this point, and this difference, the distance between here to here will become under the interceptors. That is b. This value is b. Rotation is basically m. Rotation is basically your m value. Okay, so till now, if anybody have any problem on understanding this concept, then please ask me. I'm just giving you uh, okay. Currently I have just uh, teach you that line equations, how line equation is going to work, and maximum minimum with AI. Okay, till now I am now I will be moved to the linear regression. So if anybody have any questions on this one, please ask me. No one have no doubt. Okay. So we are going to move for second things. That is today I will teach you what is the core concept of linear regressions. Okay, we have data set. Okay, okay. So let assume that these are our input data, and with the help of this input data, we have to predict this output data. AI is going to do it like this only. Okay, so whenever you are going to represent this data into the graph of x-axis and y-axis, this is x and this is your y. Okay, let's assume when we draw this point to the graph, we get line like this one. Okay, so we have to find out this best fit line. Our target is to find out this best fit line. Okay, but while finding this fit line, maybe situation will be like that. We got this line, we got this kind of this type of line, but these are the not a correct line for the this current set of data. So what how what we will do, we just going to minimize the error. What we will do here, we just find the error between our original data. Like if the input data will be like this one, so the output data will be going to this according to the line, but the correct answer is this one, right? Here you can see for the x-axis, if we focus on this point, uh, our correct output is going to be like this one, but according to the line we are going to predict, we are going to get this line. Okay, so this line is not a truly 100% correct to the uh, correct for this x-axis. So the correct output is going to be become y. Okay, let correct is y, and uh, in blue color, focus on the blue color. This is only axis. Okay, just focus on the hair. This is y predicted. Y predict means what value we are predicting from the line. And in same way, when you are going to train this AI model, this line is only going to predict the value from the line only. So it is going to take very little amount of the storage. Okay, while training while training this AI model, we just we just for this data, we have no any other options that we can change the line to make best fit. Okay, if we will be choose different line, then it is not going, their error will be becoming their error is going to be increased for every point. So we have to try to minimize the error. Okay, so there is one concept in statistics, we know that this, or we can say that slope formula. Okay, what we are going to do here, uh, y sorry, x, one second. Yes, so we have already a formula mx plus p, where m is going to be a summation. We are going to add all the value, all the possible point from the predicted line to the their original point. We are going to find out each point's error, and we have to sum all of them. Okay, so for xi, it will be something x min with the help of mean. Okay, this all the concept will become into the statistics. Just focus on this one. Okay, find out the minimum value, because this slope have only one m values, right? So that value is going to find by this equation. Okay. In few minutes. So from these two ways, we are going to find out the value of m and b, and we are going to implement here, and we will get this fit line. Okay. So it is, you can see here, it is not correct way, correct 100% correct. And if your model is going to be 100% correct, it means that your model is overfitting. Overfitting means like uh, this is your graph, right? This is your point, this is your point. And what you have done, you have just created one line that is crossing to each, try to catch all the points. So this is a not right way. If new point will become like from here, so it is not going to predict, not going to predict is that this is correct or not. So because of that, we try to focus on minimize the error. So single line is always going to work for every kind of data. Okay. So that's why we not always try to make always perfect line. We always try to get minimum error line or line error. How much storage this will be take? If you take that m is like a floating value 64 bits, this will be get 64 bits, nothing, not more than more than that. But the our main issue is that to how what will be the value of m, and so how will we get the m value of m from here. From this equation, we are going to get the value of m, right? So, anyone have doubt on this? Please comment. Otherwise, I can pursue to forward. Yeah. So now we will move forward. Okay. So let uh, firstly we are going to write the equations of error. Okay. Let assume. Uh, wait 1 second. Yes. This is our line. Again. Okay. Think like that. These are the our error points. Okay. This is our best line, best fit line. Okay. After minimizing to the zero, mean will be become zero. Okay. You can forget this one if you, this doesn't matter here. Okay. So let that, this is our best fit line, this is our best fit line, and we have to minimize. So for minimizing this, we have to calculate error for each and every situations. So how we will calculate the error? These are the errors, right? This is the wrong predictions, but still this line is fit, good line, best line. If you try to find out some better point, better line from this, you are not going to find, because this line can explain all this code in single line. Okay. So our target is to minimize this error. So what we are going to do, we are just simply going to do the prediction value that we have get. Okay. Y I. Okay. Sorry, yi had, we are going to subtract this value to the from the yi. Okay. Means what it means, like if we have a data set, these are the input data. Increase the size. If these are the input data, we are going to predict y data. So in first time, we already have output, some output data are given, because in supervised learning we know that, right? Input and output both are given. From these equations only we are going to find out. So by reading learning from this data, by learning from input data, we are going to find out this output data. Okay. And this learning data is here, right? And this learning data is generating this kind of errors. So how much total error? This one, original errors, original value, these green points, okay, original. And y hat is given by the this line value. These points are y hat. These points are the y hat. Okay. So the thing is that, okay, whenever you are going to subtract, like if it is a negative value and it is let them like a zero, okay, and make it one as a positive value. Just considering, okay, any value you can put. Like if this will be five, then down to the five, it will be minus four. Let minus four, -4, and upside will be +4, like that. Okay. So because of that, what I am telling you, if if you will be add all the error, we are going to add all the error. If you will be add all the error, what will you get? 5 minus 4, like this. Let them 4 plus 4, okay, means that is 9, and this is going to be your uh, 1, right? So but what here we can see that the distance from this line in upside, this is 4 meters, 4 units, and in bottom same 4 unit. But when we are going to add simply this one, it is going to become this value is going to become 9, and this value is going to become 1. So this is not a correct right way, right? So in place of this, what we will do, we are just going to square them. So we are going to maintain all the distance, okay, from here and here. And also, if we are doing a square, it means we can differentiate, right? Differentiation is possible for this equation. That's why always we choose y loss function, y minus y predicted for the linear regression. So after doing all these things, what will be the our error function? Let them assume as a s. Okay. Some people use as a different words. Okay, fx. Some people use fx. Some people use l, etc. Okay. So don't get confused by the these symbols. We just have to focus on s. Okay. So basically, what is s is going to be? It is going to add all the value, all the error points from the y, that is original point, minus the error point, that is y hat, for the I, for the particular point, right? This is the, and a square. Why a square? Because we does not want mismatch the value. We don't want to make messy, okay. So after a squaring, we know that negative value is also going to become positive. So it will be maintain all the error in right frequency. And a square also help us to differentiate us, right? Differentiations is possible. So it will be help us to minimize the error that I told you na, this graph, right? So if differentiate, we can, if we going to difference this one, we can get tangent value, and we can try to reach to the this point, okay. So these are the our target. That's why we choose equations s is equal to summation of uh, y original value minus y predicted ka whole square, okay. So now 1 second. Yep. Okay. If anyone have any doubt on this topic, please let me know. Okay. So yes. So so what we have for the function fx, we have already summation of yi minus y hat ka whole square, right? Or we can call as a s. So currently we are going to differentiate this one. with respect to x. Okay, so after differentiating this one, what will we get? uh, huh, Here also, what is y is prediction. It is coming from the line. That line is x x1. Okay, if any point is 1, then x1 into m plus b. I will be writing correct way. Y here we are just going uh, summation of, let I will be writing, I will be writing for you again. Currently let's just focus here. Y minus m xi plus b. Okay, so this is your equation. Okay, now we are going to differentiate this whole equations. So what we will be get, like ds by dm. Summation will become summation for the all constant value. A square will be come here, and it will become 2, right? And these are the minus, right? So it will be become, firstly we have to write yi minus mxi plus b, and again we differentiate x. Here I have written, we have to write x, right, with respect to x. No, sorry, m, because we have to find out the minimum value of m. Firstly, we are going to find out the slope value with respect to m. Then we are going to find the slope value with respect to b. Okay, interceptors. So here m. So m, what will we get here? Minus x one. Let, okay. So after concluding this all things, we get minus two yi minus mxi plus b and multiply by x1. This equation we will get from the, uh, after differentiating this one. Okay, again now again we are going to differentiate with respect to b. Same equation s equation is not going to change. X equation is still going to be like this only. Okay, so what is, again I'm going to write you, for you these equations. What is the equation? Y I minus y predicted, that is m xi minus, plus b. This is our equation by ds. Okay, and a square. Yes. Then again, and this all there are in summation form. So again, summation, differentiation of a square will be equal to, these are the basically chain rule. Okay, 2. Okay, minus b, if you multiply minus b, then it will come minus 1, just minus 1. Okay, so our differentiation is going to become mx1 plus b. Okay, into minus, uh, yes, into minus 1. So we can move this minus to the this coefficient number. So it will be look easy for us, and we get equation like mxi plus b. So the our final equation for the b will become this one. Now our target is to find out the slope. So for finding the slope, what we do, we just make equals to 0. Okay, so what will we do? ds by db is going to become equal to 0. And what is ds by db? We have this equation. This equation is our ds by db, right? So minus 2 summation of yi minus mx1 plus b equal to 0. This summation is for everyone, right? So we can summation follow distributive law, so we can submit everyone separately. And this 2 is constant value. In differentiation, whenever you are going to get constant value, that is not going to harm any, that is not going to harm us. Okay, this value doesn't harm us. It will be, in future times it will become negligible, so we can ignore this one. We can ignore. Okay, we can just don't focus on this one. Okay, we are just going to focus on this equation, because these variables only matters for us. Okay, so what we will be get after making this one 0, we get summations yi minus, okay, here also a small bracket. Okay, mxi plus b. This is y predicted. Again I am telling you, if you are getting confused on this one, just get reminded that this is predicted value what we got from the model. Okay, this is nothing but reverse engineering. Okay, so don't focus here. And like now I will be distribute them. Okay, so we get yi minus minus, this is minus, right? Minus summation of m xi, again minus for b, then minus summation of b, right, equal to 0. Right. What we can do, we can multiply by n. Okay, summation already contain I equal to 0 to till n, right? N number of data, it defined n number of data, means whenever n rows, n number data, this is I. Okay, for every row. So when we sorry, multiply, not divide, we are going to divide by n, we are going to divide by n. Okay, so this formula is going to become easy for us. Okay, and divide by n. When we are going to divide for n, all from LHS and RHS side, what we will get? We get yi by n minus summation of mxi by n minus summation of b by n equal to 0 by n. It is also currently it is 0. After doing everything, it is already going to be 0 only. Okay, so now yi, y is predicted value. It is we can tell that this is the mean of our input data. Mean mean this is the basically mean of mean of our input data, right? And this is mxi plus b. M is constant value, so every time m is going to be take common, but xi by n, summation of xi by n, right? This is also mean value of input data, right? Input data means the data we have provided by the uh, provided by the CSV file or anything. Okay, b b is also going to be input, right? If b, we can add b multiple time n times, so it will become nb by n, and it is currently also it is 0. Okay, so we can write this equation as a y bar minus m time x in mean minus this n is cancel, minus b equal to 0. So b is going to become b, we can move there, m x bar minus y bar, right? No, 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 this will become here, yes, sorry, by mistake I have mixed the sign. Don't uh, minus b goes there, means we got y bar minus n x bar, and this equation we get, right? This equation we get the value of b from the slope of the line. Think like that, we have slope of the line, from the that slope of the line we get the minimum value of b. But in simple word you can understand, either this is here the value of b to minimize the error, we have to minimize, right? So this value, I have written this same value in first time. Okay, let, I don't know where that is gone. Okay, 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 okay. Now, so let us assume what we get. uh, we get b equal to y bar minus mx bar. If you can watch, so how we get this value, we have understand, right? Any person have doubt to get the value of b. Now we are going to find out the value of m. Okay, so again I will be doing for you. Okay, we have uh, with respect to m, we have to find the slope with respect to m, and s is nothing, s is summation of our original value, our original value minus our predicted value का whole square, right? So, and y is nothing, y bar is nothing. This point is coming from the line, that is mxi plus b whole square, right? So we have this line. This equation is very important. That's why I'm writing you multiple times. Okay. Okay. So now we are going to differentiate this one with respect to a square, and I have already done. Again, if you will be, if you remember in my just a few times ago, if you have written somewhere, then you can get that one. But again, okay, I will do you for you. Okay. So our equation is going to become yi minus mxi plus b whole square, this one, right? And currently we got the value of b as a y minus mx bar. Okay, so our new equation is going to become like yi. Just I'm doing, just put the value of b in equation, nothing more than that. Okay, yi minus m m x xi plus b value is going to become y bar, that is mean of y, right, with slope into x bar, right, and their whole square by dm. It look complicated, but it is not that much complicated. Okay, so after differentiating this one, what we will get? Firstly, we differentiate square, so we are going to get two. Uh, One thing I have missed out, that is summation, right? Summation I to n. Okay, so summation to yi minus mx I. This whole equation is going to be in minus, so minus y bar plus minus m x, right, bar. And again, with respect to m, we have to do differentiation. Okay, so one time we will get xi, and one time we get x bar, so we will get minus xi plus x bar. This is the differentiation of dm with respect, differentiation of ds with respect to m. This is our value, right? Again, we have to try to minimize the value of m, right? Minimize means we have to get accurate value that is going to help us to find minimum error for the all the points. Okay, it may be I sound some complex, but it is easy. Okay, again I'm going to explain you. Okay, going to tell you, our target is to make m and b to minimize means not minimum. I'm not telling it that we have to get minimum value, we have to minimize the value, so that the error is going to be minimum. Error is going to be minimum, so minimum error means best fit line. And by using slope, we can reach to the bottom of the curve line, as I told you. So that's why I differentiate. Now I have just differentiate means we are just finded the slope of the line. Now we have to find the slope that value is going to be equal to 0. Why equal to 0? Means tan theta is going to become 0. Tan theta 0 is 0, so minimum error. Still it is not going to be 100% accurate, that's why it is never going to touch the x-axis line, but graph will be some like this only. Okay, but our minimum error is going to be reach is this one only. Our target is to reach minimum global only, minimum global, or yeah, minimum global. Okay, so again, we are going to make this equations is nothing but ds by dm, right? Again, we are going to put equal to 0. If anyone have a knowledge, prior knowledge on maximum minimum, then he can understand very easily. Okay. So now what we are going to put, ds by dm equal to 0, means these equations equal to 0, right? So what we will get? minus y bar minus mx bar bracket minus xi plus x bar, okay, equal to 0. Okay, simple, in simple way, what you can do, divided by 2. So divided by 2, it is not going to harm, right? So constant value doesn't make that possible. That's why we exclude this 2 from the equation. Okay, so now what we will do, if, these both equations are in different format, so we are going to make them in single unit. We are just going to multiply them, okay, or we can calculate them like this: y I minus y hat we put in one section, okay, and if you take the common m from both of them, what will you get? M x I minus, sorry, minus, then flip up plus x bar, okay, and bracket x I minus x bar equal to 0, right? Right. Again, now summation xi mi, okay, okay, okay. We are just going to multiply this one with this one. This is in plus, this is in plus one, right? All are in summation, all are in summation, okay. Let firstly we multiply this one with this one. So what will we get? yi minus y predicted, sorry, y mean, into uh, x I minus x bar, okay. We are multiplying with this one only, okay, and minus m, yes, this is in plus and this is in minus format. So xi minus x bar. Don't get confused why I am using this one. I have just done one thing more. I will write it. Why? Because I can see here, right? I can make equation like this. Okay. Why? Because these both are plus and this is minus. So we know already this formula: a plus b into a minus b equal to a plus a minus b ka whole square. A square, sorry, a square minus b square. We can write like this, right? Because of that, okay, I have done certain changes on here, and we got this one, okay. So now uh, our target now, m is separate. Our target is to make m separate. So now I have made separate. This all the function is in summation form, okay. So just we are going to take m as a common, okay. If take m as a common, this will be become, this is minus, right? So I have sent it this one to the uh, uh, right side. After right side, we have going to send this whole part from this one, and this one is going to set left side. So what will we get? Summations of yi minus y bar xi minus x bar divided by summation of xi minus x bar ka whole square. So we get m equation. From this we get all m equation. This is nothing but simple mathematics, okay. We have just gone through the simple mathematics and we get the value of m, okay. So in this way we get the value of m, and this is value of b. After with the help of m and b, we can create the line for every point, right? M xi plus b. So m formula is this one, and b formula is y bar minus mx bar, okay, right? So in algorithms, we have already written all the algorithms, linear regression algorithm. From that, linear regression is internally going to do all these mathematical operations. We just have to focus on the use cases of the equation. But how this m value and b value, m is slope and b is interceptor value. slope intercept value is going to find out from the equation by using this method. Okay. Okay. So after all this kind of the operations, we got the value of m and b. Now, now we are going to see one practical implementation. I have already done for you. Just I am going to show you. Okay, so just look carefully. Okay, like here you can see what I have done. I in from Scikit-learn or from Python. I am using Panda. Panda basically used to make read the data frame. Whenever you are going to work with data frame, you need you need Python. You need Panda. So to make numerical calculations. Then I use plot ly for plotting the graph. Okay, graph to see data. Okay, how data is going to work. And then I have uses some matrices. Matrices nothing but it is a way to calculate the error. So from here we are going to calculate all the error. Okay. Now see, we are, I have created here XY dummy regression data. Okay, and sample will be 100 and two features. I am going to take two features. From two features, we have to find out one target value. Okay, one feature. We have to find out one feature from two features. Okay, so if we have two features, means our equation is not going to be like this. Our equation is going to be like m little bit complicated, but it is okay. Okay, m1 x1 plus m2 x2 plus b. Okay, because we have two features. Okay, these are the input for model for model. Okay, and y will be the predicted value, right? So for two features we will be equation will be like this. I have shown you this equation only. Okay, but rule will be same. In same way we are going to only differentiate and we are going to find out the value of m1 m2 and b. Okay, so here I have taken two features. Okay, and currently then I have shown you that what are the datas present here. So you can see here, if we have like this two kind of feature one will be have 0.79 and feature two have minus 0.88, then our target value will become 35.5. And if like this feature one is going to be 0.45 and 0.67, then our target is value is going to become minus 2 7 27.14, like that. Currently it is looking very complicated, but it is not that much complicated. It is very easy. Okay, whenever you are going to get data, you are going to understand, like sometime you are going to get health data. Okay, or sometime you are going to get any stock market data, etc. But all data is just a number. That's why I'm just taking any dummy number. So so it is going to make everyone easy to understand how everything is going to done. Till now I don't understand what are the patterns are present in this number, but I'm going to find out, right? Because currently I have made this data. I have getting this data from dummy. Okay, from dummy. Okay, I have just made them. Okay, it is just like in Python there is something called random number generation. So just I'm generating number random number. Okay, then what I have done by using px what px is nothing but uh, poetry.express. Okay, from that library I'm using one library that is wait, I will show you poetry 3D. So what it will do, feature one it will be so, feature two it will show, and target value it will be so in the graph. So here you can see, right? I will show you once again. Let make me small, very small for you. See, this is our visualization. Okay, so feature 1 belongs to this line, feature 2 belongs to this line, and with the help of feature line our target value is going to be here. Okay, if feature 1 is minus 1 and feature 2 will become 1, means this point. Okay, approx, I'm just telling you approx, okay, maybe forward, some forward, okay. So from that line it is going to make uh, we are going to make the predictions, okay. We have to find out the target value. So okay, uh, I have used the linear regressions random data, so it is going to generate random uh, linearly. So you can see that it is, you can view here, it is making one line, okay. You can see from this angle of line. If you see from here, it is going to be a scattered here and there. So this is not a right viewpoint. You can view from here, okay. This is the this, okay. So here you can see that this is making a kind of line in 3D. It is in 3D, but you can view, right. Now what I have done, basically whenever we have a data set, okay, we have let we have 100 numbers of line, okay. So we are not going to use all the data for the making the model, because after making the model we have to test our model. Is that my our model is going to work well for the testing data or not? Because of that, what we do, we split the data into two parts, not 50-50. We are going to use most data points for the training, but less a small point like 20%. Sometimes we use 10%. Sometimes we use 5% data for the prediction. Okay, so that we can provide input data, and we try to get that is that model is going is predicting correct value or not for the testing data. So that's why we use train test split. Train is basically used for training the model, and test is basically used for testing the model. Okay, and a split means we have dividing the data point into two sectors, okay. And here you can see we have taken zero point 0.2. It means 20% of the data is going to be used for the testing purpose, okay. And uh, these are the variables, like in x train x data will become y, x test data will become x test and y test data are for the testing purpose. Means while training the data we only use x train and y train. We in supervised learning, what we do, we provide both the data, input data as well as predicted data. That's why, okay. So here you can see now I have imported linear regression from sklearn, and then I make one object of linear regressions, and in linear regressions we have one method called fit, and in fit we passed x train and y train. Y train because X train is going to be training data, and Y train is also in training data, but it is the output, it is the input. Okay. So now after executing this point, let, uh, we test Y prediction. We test. We provided X data, and what we get predicted value. Means after x train and y train, they that equation is after applying all the mathematics, means these equations and b, after doing all this equation, he find out some value, okay. I will show you in bottom. I have already written that what are the value of our slope and interceptor. I will show you, but here just focus that from the x whole data, from x train data we make model, we have made the model, and after that we predict for the test value. We get some value, right? After getting some value we get y predicted, that is y hat, this one. I will show you. Okay, i I thought I guess miss out somewhere. Yeah, here. Yeah. So here you can see, right? I have told you y hat. This y hat is nothing but the value is predicted by the model. Okay, so this value and but in data set we have all both value, right? So we provide now extract data and what data I predicted, and we find out the error. So here you can see our model is not that much correct, but it is correct, somewhat correct. These are the different way to measure the error. Okay, MAE, that is mean absolute error, MSE mean a square error. Some used to a square, some is to so these are the different techniques. You don't have to worry about this one. Just you have to focus. So after doing this, we got value like this one. Okay, and our target is to minimize this value. Okay, but if you are working in any company, then you don't know what will be the minimized value. So that's why you have to perform this operation multiple times. Okay, if you perform this operation multiple times, you will be get proper value. Okay, and that value is not also 100% correct, but you have achieved in the right way. Okay, you have already achieved what will be the value and what will be the not. Okay, so you have multiple models. Currently I have only tested on linear regressions. You can also use SVM, support vector machine. You can use L1 regularization. You can also use L2 regularizations. You have to test in all kind of the models. You have to test in all the models, and then you have to check that MAE, MSE, and R2 score. These are minimum. Whatever model have a minimum value, that model you are going to use and deploy that one for the production. This is the your target only. Okay. Now, I have here showed that coefficient where coefficient is nothing but slope. Okay, so we have two, right? We have two value, means we have m1 and m2 will be two values, right? From this equation you can see, because we have two input data. So m1 and m2 is going to be 2. Okay, so that's why here you can see in coefficient we got two value, means slope value. Okay, and second time we have interceptor, that is b. We get a value as a b like this. Okay, so this is all about the detailed explanation of linear regressions. So if anyone have any thoughts, so please you can comment. Okay. Yeah. Okay. So okay, we can conclude here. So today we have seen that how linear regression is going to work. Okay. Tomorrow I will be show you logistic regressions, as well as I will be. I'm not going to show in direct way. In same way we have to do all the things. But tomorrow I'm going to show you one. What will say? I will going to go through the deep learning section. Okay, so in that deep learning, what we are going to do, how everything is going to work, and how neural network work. Okay, so tomorrow we will be see about perceptron, how perceptron work. Okay, why? Because in linear regressions we can create only single line. Okay, but for more complex data, okay, for more complex data, what we have to go through, go by neural networks. Okay, so that's why tomorrow we will be go through the neural network, and we will be see how a neural network is working. Okay, so thank you everyone. Okay, bye.